So today we are going to discuss on the dimensional management and what capability we have in GD&T and Tolerance Stackup. So currently we are working on multiple software. So before that, I'll just give introduction about our company and what we are doing and how, like, what are our skills and what type of team capability we have. So yeah, Shyam, next slide. So about noCnX, noCnX is almost 5 years old company, and company has started in year 2019 with the aim of supporting the customer into product design, development, and simulation services. And mostly into the services side, we are 60 to 70% of our customers are from automotive. And with automotive, we are also working on different areas like off-highway agri equipments, then consumer goods, and also into medical and healthcare. And we have a team base in Pune and Bangalore. And some of our team is also supporting to customers which are out of India. So we have customer base in Singapore, India, then UK, and then USA, and also the Canada. So these are our customer bases, and mostly the support goes from our office in Pune and Bangalore. And in terms of team skill set, so mostly we have the senior engineers who are with the expertise of 8 to 10 years of experience. And then we have the engineer, the experts, you can say the experts and engineers who are almost 4 to 5 years of experience. Then overall, we have, you can say the senior, most senior and SMEs who are having expertise of 10 to 15 years into industries like automotive and off-highway. And most of our customers are also in this particular field only. Yeah. Yeah. So maybe Sham, you can explain about the software, like what capability we have and what type of case studies we have.
Yeah, thanks, Azim. So here, coming to dimensional management, mostly deals with the dimensions, like how we manage the tolerance and those things. When we manufacture a product, it won't be that much accurate and precision. So we need to ensure whether it is reaching the customer specification or a design specifications, in order to get a quality product out from the manufacturing. So these all things will be under dimensional engineering domain. So you can see a picture here, uh, where a car BIW part exterior is slightly inside it, so it is not exactly matching to the surface. So these kind of aesthetic purposes, everything will be looking by within the 3D stackup software with the dimensional management. And so here you can see a transmission which is having some speed sensor, and it has to exactly match the axis of this input shaft, center to center. So if it not does so, its speed vary, maybe it will not be counted through the sensor properly. So for these activities, like it has to be precisely kept, and how it is assembling the sensor assembly, everything to be needed. And it should be like it should be put in such a way like as per the planned procedure. And coming to the skills required for the dimensional engineering, mostly deals with the GD&T part and the metrology. And also we are having some stack up softwares like CTOL, 3DCS, and VisVSA, and some SPC tools like Minitab, statistical process control. Yeah. And coming to the advantages using dimensional engineering tools, it will be easy to communicate. If some, like every product will be reaching to the final stage by stage. For example, alpha, beta, gamma. So in each stage, we have to like communicate the flaws where it is required. flaws to the engineer or product engineers, we have to communicate with them using some report or story dashboards. So it will be easy, and also the time saving and money saving, since so this each sample will be built, so before that we'll be having this simulation, dimensional simulation within our tools, so it will reduce some prototype time. So if there are some any like error like fitment or clearance error, so it will be we'll be knowing that in prior, and we can avoid that mm, uh, that mistake to be happen, and it will give a smooth flow for the manufacturing. And also it will simplify the gauging requirements and tolerance analysis, especially for long chains, long tolerance chain. We cannot keep in an Excel sheet, or if any 3D measurement is there, we cannot keep in Excel sheet, and it will takes much time. So in this tools, by using these tools, we can get it in short time, and also big loops will be solved within less time. And also it will helps us to find root cause issues. Suppose if we have any PPAP report from the production, so we can see where the from the PPAP report where the dimension is going away from the specified limit. We can include that limit in the tolerance stack up software, and we can see what is the root cause of it, and how we can rectify whether the tolerance should be modified, or any tool change or tool correction need to be done. So we can get some root causes using that. And also it's also like, as we said, like 3D measurement. So if we see a vector measurement in a 3D in XYZ, so that cannot be solved into like 1D stack up analysis mostly. So those kind of things will be within the software. We can give some conclusion, and we can take that measurement.
Okay.
And coming to the process here, so it will dimensional engineering will support from end to end, right from the concept to the quality, where the product outcoming. So this acts like a bridge between all domains. Suppose within the concept we can say like if we get a rough concept, we can see like what are the minimum clearances required, what is the maximum clearance should be taken, or any specifications from the customer, or interface measurements, we can take that. And coming to product engineering, like I said, each phase we can reduce some prototype costs using this dimensional engineering. So before producing the prototype, this will be like a like checkpoint where whether this product, whether this part is okay or not, whether it is ready for manufacturing or not. Also it will we can simulate as per the plant point of view, like how it can be assembled in plant, whether it is a robotic assembly or it is a manual assembly. So if it is a manual assembly, how can we simulate in 100 different ways, or any different ways, so that it will be always fit it right, and the functionality it is meeting, so we can check that. And quality point of view, we can check in a PPAP report whether it is meeting that quality or not. If something goes away from the specified limit, we need to again ensure like how it can be met, or we need to see. And coming to the manufacturing, so each component we can many companies will be giving to the suppliers outside, like they'll be dealing with suppliers mostly. So this also helps us to choose which supplier is a benefit for us, like which supplier is giving a better result, so we can have that. And responsibilities for dimensional engineering, it includes like feasibility and functional requirement, whether it is meeting for a particular part or not, we can see. And it will act like a bridge between design teams or studio teams, and creating, we can create GD&T within that tool. Also the design validation or GD&T validation can be checked here. and we can create measurements within the tool itself. And so we can validate in a different different assembly procedures, and we can give a report for that with a bell curve and the contribution list. So it helps us to see whether the product is meeting the functionality or not. So this is a small case study. Uh, so basically, this is a kind of currency printing machinery. We have a client from Europe. So here, what challenges we have faced is, so we have to give them some design proposals or tolerance reduction, or to meet their tolerance variation within a specified limits. We have to give some design proposal or a tolerance proposal, and also we need to negotiate with their suppliers for the tolerances, and also we need to create a same assembly situation as per the plant, like how it is getting assembled in the plant. And also we need to
Some,
give a,
yeah, 1 minute. Citol is your software name or?
yeah, CTOL is a software actually.
Okay, yeah,
Yeah,
continue.
we will show you the demo also after this presentation. We'll show you.
Okay.
Yeah. So, and also we need to give some GD&T recommendations if there are any drawing errors or something. To reduce the variation, we need to give some GD&T recommendations, like whether it's a reduction of tolerance or something we need to give. So these are the challenges we faced, and our solutions for them is to finding out the tolerance variation for the required objectives and giving them in a major contributors, so you can see the tolerance chain, since they are having a long chain, so there are a lot of contributors, so each thing need to be specified along with the with some comments where that tolerance is taken in the drawing. So, and we have run with CPK 1.33 as per their assembly requirement, and a CPK 1 as per their requirements. And also we ensured like fit form and functionality of the parts. And we have given some GD&T proposals as per ASME and ISO standards. And we are also involved with the supplier meetings with them and preparing technical reports. And also conducted design reviews using PPAP, which we got from the suppliers. The benefits got to the client is 20% of cost saving. Like also the time is reduced, since they are not put so much cost into the prototype also. And also the prototyping time got reduced for them, and we have provided them both statistical and worst case results with a summary, like what needs to be changed in the drawing. So we have given some insights to them. So in the next revision of the drawing, it was further modified, and right now they kick off for the production. Yeah. So this is a small case study regarding this printing machinery.
Okay.
Yeah.
You mentioned based on the supplier, the tolerance can be defined. So by that, that's based on the plastic, sheet metal,
Yeah.
casting, or
Yes.
oh,
Yes. Everything like we will be giving some drawing tolerance. After that, the supplier will negotiate with us whether he can't, if he can't achieve that tolerance, he'll ask us to increase something, which might not be beneficial for us. Again, we have to validate within with this software, and we have to showcase them like this is a important feature for us. Hence some importance is required for this, so it needs to be precisely missioned, and we need to achieve some tolerance like this. Sometimes we can ignore whatever the supplier is telling us like to increase the tolerance or something. If it is not functional point for us, we can accept that tolerance proposal from the supplier. So that is like a win-win situation for both of us. So
Yeah.
sometimes we cannot agree to the tolerance. So we need to, for validating all these things, and we need to require some dashboards like this to show them like a proof it can't be achieved, and further what if solutions, like in order to achieve the tolerance, some other solutions also will be giving. Out of that, supplier will be choosing one, uh, which further cost and which will not impact their cost also.